Welcome to Bugged Out, the bite-sized podcast where we explore the art and science of functional verification and how to get the bugs out of the world's most complex chips. Hi, I'm Harry Foster, your host. This podcast was born from a simple idea. Every chip has bugs, and the real challenge is how fast we can find and fix them. With Bugged Out, my goal is to bring you candid, focused conversations with the people shaping verification today, from engineers, researchers, tool makers, and thought leaders. So you can hear what's working, what's challenging, and where we're headed. Today, I'm thrilled to have with me Jake Wiltgen, who's Director of IC Verification Solutions at Siemens EDA. Now, Jake has a wealth of industry experience and is an expert in safety critical systems, functional safety standards, and DFT. Jake recently co-authored a white paper titled Accelerating DFT Sign-Off with Questa One. In the next few minutes, we'll talk about why DFT is more critical than ever, highlight some of the key ideas from the paper, and get Jake's take on where the industry's headed. So my guest today is Jacob. Jacob, welcome.
Glad to be here, Harry. Good to chat with you.
So let's start out. First of all, before we get into technical details about the paper, how did you first get pulled into the world of design for tests? I'm just curious. Was it accident, curiosity, trial by fire?
Well, my journey into the world of DFT, I guess, came from multiple angles. I guess the first aspect was part of my role as a functional safety solutions manager for the division. And so we were seeing a growing need for fault grading capabilities to evaluate the fault coverage of functional patterns to complement the coverage obtained from structural scan. And so that was one aspect. And then I'd have to say it was around 5 years ago or so, we were hearing about the challenges and other aspects of DFT verification. Extremely long-running serial simulations, this growing volume of patterns that need to be verified. And while that pain isn't, I guess, necessarily a new thing to the industry, the problem was getting worse as chip complexity grew, and directly correlated to that complexity of test architectures and implementation to solve the primary care abouts, such as time on tester and test power, is the verification. And so we saw the verification volume growing in lockstep as the complexity of these DFT implementations grew.
And just for fun, if you had to explain DFT to your grandmother or maybe a brand new engineer, how would you sum it up in a few sentences?
That's a good question. I think the answer is certainly different between my grandmother and a new engineer. I guess so. Here's the engineer version. The primary objective of DFT is to deliver high-quality silicon into a target market. Silicon which is functionally correct under all operating conditions and parameters for that end market. And to do this, capabilities are built into these chips to test them after they've been fabricated to identify if any defects were introduced during the manufacturing process. So that's how I would summarize DFT at a high level to a new engineer.
It's a great description. Let's move on. For listeners who haven't downloaded the white paper yet, could you talk about maybe 3 key takeaways from the paper?
Well, I'll start by saying that not all chip designs are equal, but for many in the industry, the key takeaway number one is that the volume of verification and DFT verification specifically is growing significantly. And simulations, especially those long-running serial simulations, are taking into the many days, if not weeks, timeframes. And oftentimes those final sign-off sims are on the critical path to tape out. And then building on that, the second takeaway is that it's paramount to deploy the latest verification technologies, which are tailored to DFT simulations. And so what you'll see in the white paper is that Questa One DFT simulation technology is purpose-built to deliver the performance, the user experience to maximize productivity and accelerate sign-off. And this really provides teams the flexibility during that critical decision time, whether or not to tape out or not to tape out, to either bring in the schedule or to add additional verification activities, additional simulations to further reduce program risk. The the final takeaway I would mention is that beyond pure simulation, there's a number of verification technologies that are available to address current and emerging DFT challenges. There are fault grading solutions within Questa One to complement the coverage obtained from structural scan, and also hardware-software co-verification technologies to verify in-system test implementations.
All right. You also mentioned that DFT sign-off can sometimes become a bottleneck at tape-out. Why does this happen? And how does Questa One help relieve this bottleneck?
The quick answer is that there is a critical period between that final netlist drop and tape-out. So during this time, the final patterns are generated, you execute your zero delay simulations, and then in parallel, that netlist is delivered to physical design. Now, once PD is completed, there's a desire to hit the tape-out button. But those final DFT timing simulations need to be executed, and there's an immense amount of pressure on those teams to complete those sims as soon as possible. And so with serial simulations reaching into the weeks in some cases, the quick execution of these simulations is paramount. And this use model was really a key focus of Questa One DFT verification in that initiative. And so we work closely with Tessent over the last 4 or 5 years to deliver orders of magnitude performance acceleration over the existing solutions in the market.
All right, let's move on to some broader DFT trends. You highlight 3 megatrends: technology scaling, design scaling, and system scaling. Which of these keep engineers up at night the most, or is it all of them?
So I know you're asking for one, but I'd say that the trends in the technology and design scaling, which encompasses really the growing volume of DFT verification required at both block and top level, is what challenges engineering teams the most. And EDA plays a critical role in managing this volume. But we don't see this as solely what can be done in terms of performance. As kind of mentioned previously, we've worked with Tessent closely, invested heavily over the past 4 or 5 years in accelerating runtimes across compile, across optimization, simulation, but also in the flows to really deliver a streamlined and intuitive user experience as users navigate between traditional test flows in Tessent and the verification flows within the Questa One DFT verification solution.
So reliability and aging silicon are big concerns today. How different are these challenges compared to what engineers faced, let's say, 10 or 15 years ago?
So I'd say inherently the objectives are the same, but the world is very different now than it was 10 to 15 years ago. We live in an age where AI is becoming embedded in almost all aspects of life. We have semi-autonomous vehicles joining human drivers on the road. Silicon can basically be found in nearly every household item that requires electricity these days. And so these systems are incredibly complex, built on technology nodes now measured in angstroms, with potential defect sites ranging into the many billions of nodes. So as a result, DFT has had to evolve, delivering new test architectures, new fault models, more advanced feature sets. And alongside each of these innovations comes a verification task and objective. And so this speaks directly to the increasing volume of verification. But in addition, there's also verification activities that are perhaps foreign to the traditional DFT engineers and their verification responsibilities. This includes the ability to run fault simulation to fault grade functional patterns, or the ability to build complex test harnesses supporting the co-verification of hardware and software responsible for delivering pattern data over high-speed protocol. And so, if I had to summarize, there's this growing verification volume, and there's also this kind of new paradigm of verification that's now required to sign off on your DFT.
I love the section on in-system test. Could you paint a picture of what in-system test actually looks like in practice? And let's say something maybe for automotive or a data center.
Yeah, and this comes back to your previous question about aging silicon a bit. So what we've seen in the past is that companies are pulling known good working silicon out of their end application because there's really a blind spot on when these devices will actually fail. And this mode of behavior, of course, it directly hits the bottom line. And so with the introduction of in-system test capabilities, diagnosis can be performed in field to identify not only when a chip has become defective, but even monitor the health of silicon to predict when a chip will malfunction. And so what this allows companies to do is to pull silicon closer to the failure point and extend the longevity. So examples including in-system tests would be to predict the failure of silicon sitting in data centers and replace the card closer to failure. Or another example is in vehicles where this capability can be used to detect failures of safety critical systems prior to putting persons or property in jeopardy.
Jacob, thanks so much for joining me today, and it's fantastic to have this conversation.
My pleasure, Harry. It's been a great chat.
For our listeners, if you'd like to learn more, be sure to download Jake's white paper, Accelerating DFT Sign-Off with Questa One. The link is in the show notes below. Thanks for tuning in to Bugged Out. You can catch this and all our episodes out on the Verification Academy. Until next time, keep verifying and keep smashing those bugs.